value to that. So similarity wise, bag of words is better when compared to the semantic wise, it may not be helpful. So that is a major disadvantage with the bag of words. So we can also represent by using the zeros and ones. Whenever the occurrences of the word is came, we can represent as a one. Otherwise, it's going to be a zero value. So let's also implement by using the scikit-learn. You can see here we are just exporting from the feature extraction. We can also call it as a feature engineering hacks for the NLP context instead of calling the tokenization mechanism. Feature engineering hacks for the NLP related or test class classification task. So we are just extracting from scikit-learn count tokenizer. It will count all whatever all the unique words we have in a sentences. Currently, we are taking some corpus here. You can see we're taking the same example as a corpus. That means a collection of some of the statements. So we are fitting some corpus to understand the count vectorization has a function, predefined function from scikit-learn. We are taking some variable called CV. So it will create and it will hold some of the unique values, whatever the corpus value we have available. You can see each and every value assigned to some unique value, each and everything. Just now I told about how does that going to be preserve some of the values in a vectors, like some unique value assigned to the each and every word. So this representation is going to be helpful whenever you do some modeling. Okay, so you want to know about some of the unique values from the sentence. You can directly use this get futures name. You will get all the unique words whatever available in there. And you want to represent it in terms of array format. You can fit and transform. Here also you can do the fit and transform. So instead of that, just for understanding, I just given here to do know about some of the transform to understand whether it's working fine for array wise or vector wise. Yeah, so you can also read this. So and is coming from once and is coming from second. For the seconds in statement, better is also same. It is this. So these are all going to be help us whenever the occurrences came with the bag of words concept. Yeah, just some of the advantages and disadvantages. It may not be hold the semantic meaning. That's one disadvantages. And it will count some of the different words between some of the vectors like tasty and the delicious. It may not be works out with semantic meaning whenever you want to consider. And some cases, what will happen? You have to do removing some of the stop words. At that time, what will happen if you remove some of the stop words? It may not be hold that much of prioritize. I can say it may not be hold that much of containing that much of information in the data sets. Stop words is nothing but you have something called as has or is or this. So these are some of the stop words. We have so many stop words around 90 to 100. So we have to remove this. So at that time, what will happen if you're doing some modeling? It may not be hold any kind of the meaning, because these are some, you can say these are some representing of some other items or some other places maybe, but it may not be preserved that much of vocabulary kind of thing or verb kind of the thing. So at that time we have to remove some of the stop words. So when you remove some of the stop words, bag of words may not be preserved. The idea is you cannot be do all the stop words. You have to do only the few stop words. So at that time it's going to be boxed out. Otherwise, it may not be that much of integrated to understand bag of words completely. So for that we have another technique called TF-IDF. So TF-IDF is slightly better than the bag of words, but similarly, this is also some of the advantages with respect to the bag of words what we had. It's still not holding any semantic meaning, but we have to slightly increasing some of the, you can say, accurate values when compared to the bag of words. So the definition wise, you can see we have something called as a term frequency. We have two terms here. One is a TF and another is IDF. So TF is a term frequency with corresponding to this formula, number of occurrences of a word. That means total number of the words what we had in a corpus or a sentence. Then we are just dividing with the total number of the words in the document, or you can say total in the sentence. So that will preserve some value, obviously. and we are multiplying with this value, idf value. That means a log of n by small n. Total number of the documents, that means total number of sentences what we had, along with total number of number of the documents in which the word is occurring. If suppose you are just working with some word like tasty, so it's going to be occurred only once or two times, so it will print the two times here in the denominator. So in the numerator is going to be get the total number of the documents, how many documents you have, how many sentence you have, then it calculate the log value and multiply it with the tf results what you have. So that is a formula for this tf idf. Okay, you can also remember this whenever the required. Yeah, so yeah, this is a formula. You will also get at the end as a vector, obviously, for this. It will hold some other instead of taking some occurrences. That is a basic idea here. So just now I told you, this is the idea how to take the values, how to preserve the values by using the some words. So instead of taking in backup words, we are just taking has occurrences values. In TF-IDF, we are just calculating some formula method by using the log. We are going to be preserve some value like around zero point 0.5 or zero point 0.7 like that. So these values is going to be help us to understand for each and every word have a unique value at the time, because we are taking at the occurrences, right? We are taking at the occurrences by total number of occurrences by whenever the word is presented. So we can also implement by using any sample data set. We can also try with maybe the next class we're going to be discuss with Amazon fine food reviews. The data set is very large. Yeah, similarly, we will also get it from the scikit-learn feature extraction, TF-IDF vectorizer. This is also similarly backup you can do this. Even Vertivec also. Yeah, you can see we're just directly doing the fit and transform to understand about what are the different unique common words we have occurring between the in a sentence. Yeah, so you can see all the values in somewhat dimensional. They are all the values in somewhat rescaling up some of the values. We instead of getting the ones and zeros, we are getting some values because of the log value. This is how this is going to be represented. We cannot be understood because the formula is going to be looks like this, right? TF into the IDF, the value will be calculated. Obviously, it's going to be belongs to in the range of 0, 1. It may not be preserved above the 1. You will get less value is 0 and above the 1 you may not be get, only below the 1 you will not be get. So like that is going to be store some of the results, okay, at the end. And this is also still may not be preserved the semantic meaning. If I have a value called tasty and delicious again, it will give some value but it may not be hold the same meaning according to that. So that is one disadvantage with respect to the TF-IDF. Just a second. Yeah, so yeah, it will also may not be helpful that. So for that we have technique called word to vec model. So what exactly the word to vec model does, and what are the different terminology we are going to be so, and how does it going to be preserve the semantic meaning. So this is the deep learning mechanism, I can say. Whenever we learn some of the basic concepts about the deep learning, I will explain in detail. But as of now, I will explain you how does this going to be works out internally and what are the different terminology we are going to be showcased. So this is related to neural networks plus back propagation algorithm. We can also learn something called as NLP, and where we're going to be use all the other matrices we are going to be used at the end, and some of the cell states and some of the nodes by railway activation functions. At the time, that may be make sense to you to understand instead of learning just for a concept. So this is going to be represented whenever you have some sentence. It's going to be split into the words, and then what will happen? It will convert into the dimensionality. Similarly, we have seen in the TF-IDF vectorizer, and whatever the similar kind of the words you can see in this example, whatever the similar kind of the words, it will hold some of the distance between both of them, or you can say it will calculate some of the distance between both of them. And it will, if suppose it is very far away to this value, it may not be interacted, it may not be grouped together. If it is a very somewhat you can somewhat near to the distance, it will go and group it together, and it makes as a similar kind of the meaning, or it makes as a some kind of relationship between this this point to this point, like that. Similarly, this point to this point, like we have a word called king along with the queen, so it has holding some of the relationship between both of them. So you can see this word walking and walked out, both the meanings is same, right, for a verb or noun wise. So if you take this consideration, it will group together and gives as a only one vector, instead of taking only the two vectors or two dimensionals of any kind of the vector. Similarly, you can see the Spain is related to Maryland, some of the states wise and also the countries wise. It holds some of the meaning. So it will get it from something called as transfer learning also. We are going to be get it from the, you can say, you have some data frame already trained. Instead of just listening, you have a already a frame. Someone is already a trained large number of the parameters, like they have trained around 20 billion Wikipedia pages and 10,000 billion books. So you have huge amount of parameters to train some data frame. Why not to use that? You have to use this. So you have to use this, you have to apply to your NLP context, because what will happen if you cannot use this, even system does not understand your language, what exactly you are speaking, English speaking, what exactly you are English speaking. It may not be understood, because unless until you cannot provide the large data sets, it may not be understood that much of integrated to any kind of the mechanisms you want to retrieve. So we have already predefined models called Google News. We have the Google News with recordings large number of the parameters to train already, and something called as a glove vectors. So this will hold some of the meaning around with the relationship between some of the words like this king or queen or man or woman. It's already trained. This already trained by using some other good universities or some other good organization, big four organizations maybe. So they already implemented this solution. We had to call these data frames, or we had to call these functions whenever we require to do any kind of word to vec model. So for that, we need to understand something called as a deep learning mechanisms, and we can also go with back propagation mechanism. How does it going to be works out? Along with, we can also learn transfer learning. So this is nothing but a transfer learning. Someone is already learn, or someone is already implemented a solution. You have just want to retrieve that API, or you want to just retrieve from the data sets. So for that, we can call it as a transfer